peace, mercy, and blessings of God be upon you. This video is the second part of a series of videos on restoring an old car. In this video, I'll be restoring the car's radiator. This is what it looked like when I took it apart and removed it from the car. It was in bad condition and hadn't been used for years. This is what it looks like after it was completely serviced and restored, and it's back to its original, like-new condition. Follow along and I'll explain the steps of the maintenance and restoration. One important point I want to clarify before starting the practical part is that the videos on restoring this old car won't all be one after the other. Instead, there will be one video restoring a part of the old car and another video about a different problem in a different car. The goal is to address each part of the old car individually: the engine, the suspension system, the doors, the roof, everything, so that these videos are useful for owners of old cars. Otherwise, I made a 1-hour video and a text about restoring an old car, and I took it all in one video. In this case, believe me, no one will benefit at all. Let's start with the first part of this series, which is the radiator, how to restore it to like-new condition. Let's applause begin. If you've been following from the first part, you'll know that this car has been sitting idle for 6 years, never used. To remove the radiator, I disconnect all the hoses connected to it from above and below, and I disconnect the fan connector. After that, I unscrew the bolts holding the radiator in the car and remove it to begin the maintenance and restoration process. This is the radiator after I removed it. The first thing I'll do is remove the radiator fan and rinse it with water for a preliminary wash to remove the dirt that has accumulated over the years. This washing process is from both sides, front and back. Then I'll do a compression test to check for leaks. Here I have two options: either use a water compressor, which is very expensive, or use a simple locally made compression tester that's very cheap and performs the exact same function. The idea behind performing a compression test on the water system or radiator is to close all the openings to force air or water into the radiator and water system, except for one end where the water compressor will be attached. In this case, I'll get a large container of water to place the radiator in. Then, using the simple air pump that comes with the compressor, I'll force air into the radiator, creating bubbles. This side doesn't have any leaks, but I can hear the air escaping when I pressurize it. I'll then position the radiator to flood the other half. In the water, start pressing in air. Bubbles will start appearing from the side of the radiator cap and the return pipe. I'll lower the camera and get closer so you can see the source of the bubbles more clearly. Press in air again and you'll see bubbles coming out of the radiator cap and the side of its upper pipe. So we need to replace the cap and flush it. By the way, this water compressor will be useful if you have a water leak in your car and need to find the source. I'll leave the link below the video if you'd like to try it, especially since it's cheap and affordable for everyone and it really works. Before we fix the leaks, we'll need to remove the upper radiator cap. Because the radiator is made of copper and is from the older generation, to remove the solder, you'll need to use a torch to melt the solder and lift the soldered metal side of the copper casing. Then heat the solder and use a metal rod to loosen it so you can remove the casing. This step is always done with the radiator lying on its side in the position you see here, as this is the easiest position to melt and remove the solder from the radiator casing. After melting all the solder, it will be easy to remove the casing using a metal rod or pliers because it will be hot from the torch and you can't handle it with your hands. The first step after removing the casing is to rinse the radiator openings with water. Then, using a steel strip, clear all the water passages in the radiator openings, making sure you don't leave any opening untouched until you are sure it is clean. It's completely clear after you finish. You take a large screwdriver and start widening the water inlet holes from the top. This facilitates and speeds up the water flow in the radiator passages and partially delays blockages. Using a wire brush, clean the spaces between the water passages to remove any dirt or rust without clogging or obstructing the passages. Then you rinse again with water, but take as long as possible because the washing at this stage removes any remaining dirt from the fins and washes it down from under the upper casing. There's a problem here. The hose connection point is very narrow because the radiator's valve or neck is folded down. To straighten it, I turn it over and place 2 pieces of wood underneath it, then take a round metal piece and carefully tap it to straighten it and return the cap to its correct position. This is what it looks like after I finish preparing it, and of course, I'll still review it. Regarding the welding, I just want to show you the before and after difference because I had difficulty disconnecting the hose, and it will definitely be difficult to reconnect it if I leave it as is. Using a wire brush, I clean the area very well. Then I use welding flux with a torch and solder to ensure a proper weld on the radiator nozzle or neck. I secure the radiator's upper housing on the vise and use a wire brush to clean it from the inside, removing any limescale and rust. I do the same initial cleaning of the outside of the housing before welding. I take the radiator and clean the areas where the housing rests, removing any debris, cracks, or chains to facilitate the welding process. After that, I install the upper housing in its place, making sure it's securely in position on all sides. Then I give it very light taps to tighten the gap between the housing and the radiator. Add flux or soldering aid as a first step before heating the metal moderately because it's copper, which is light, not heavy. Then solder the gap between the can and the radiator with tin to seal it. I waited until the radiator cooled down, then lowered it back into the water tank. Of course, I had already welded the hole and replaced the radiator cap. I pressurized the tank and waited a bit to make sure the leak was completely stopped. Then I flooded the other side of the radiator and pressurized it again to confirm there were no more leaks. Next, I needed to reshape the water inlet and outlet pipes. This is done with a pipe roughly the same diameter as the radiator pipes, using light taps to restore their original cylindrical shape. This process is repeated for both the inlet and outlet pipes because if the pipe isn't properly shaped, it will leak water. Finally, I removed the fan sensor, which controls the radiator's cooling fan. When I show it to you, you'll understand. Why did I take it apart? Because I knew it definitely had layers of rust and limescale preventing it from reading the water temperature correctly. Therefore, it needed cleaning so it could operate the fans at the right time. The difference before and after cleaning is very clear. Then wrap it with heat-resistant Teflon tape to prevent water leakage. After that, put it back in its place and tighten it with moderate force because you're connecting it to a weak copper box. Using a regular wire brush or a drill, depending on what you have available, start cleaning and polishing all the external parts of the radiator except for the copper strips. This is what it looked like when I first took it out, before cleaning, unclogging, polishing, and soldering. And this is what it looks like after cleaning, performing the necessary maintenance, sanding, and polishing. You'll always notice that the side part of the radiator, which is the body, is metal, not copper, and it's coated. So here I cleaned that part, I sanded it and prepared it for repainting. But of course, before painting, I had to seal all the areas I didn't want to get paint on, whether it was the radiator fins or its casings, both the upper and lower ones. Then I started painting with a color that matched the car's color, which was sky blue or blue. The paint was applied to all sides, and I left it to dry for at least an hour. After an hour, I removed the tape to show its appearance before the final step, or before the stage of polishing the crossbars. Before this stage, if you find any folded crossbars, you use a nail or a thin screwdriver to straighten them to allow airflow faster, resulting in faster cooling. Finally, we move on to the last stage, which is polishing the radiator fins. For this, you use a liquid specifically designed for cleaning and polishing copper radiator fins in one step, spraying it on the plates. It can remove any dirt or limescale from them, restoring them to like-new condition without any effort on your part. Afterwards, you wash the radiator very well with water to remove any traces of the product, and that's how the radiator is ready for installation and operation. This was the radiator's appearance after I removed it from the car. It was in very bad condition. And this is how it looks after it was completely refurbished and restored to its original like-new condition. Like and share the video so that people who have old copper radiators can learn how to refurbish them from start to finish. After you subscribe, activate notifications by clicking the bell icon. That's all for this video. We'll continue together in the next video, God willing.